Hi all, this is Mr. Lim here, and this is a introduction to the flipped learning style that you're going to be using in year 11 and 12 chemistry. All right, so we're going to start off with the purpose of education and the model of memory. So let's have a look. So these are the things that we're hopefully going to learn today. What's the purpose and the model of memory that we use in the class. All right, so let's have a think. So what is the purpose of education? Let's have a think. It is to give you life skills, or what I think it is at least, is to give you skills and knowledge to tackle problems. Okay, so you're all going to encounter problems later in life, and then we want you to be able to tackle those problems well. So we need to give you skills and knowledge to do so. So how do you tackle problems? Well, first of all, you take information from your environment or your problem. So you have to, this is your problem, so you will look at it, you work out what's wrong, right? Then you take your information from your long-term memory. Okay, so you think back, how am I going to solve this? Have I encountered this problem before? And then you combine those two pieces of information, that's what you worked out from the environment and what you know from your long-term memory, to try different solutions. All right, that's generally how we deal with life. You know, we have problems, we take the information from before, we take the information from this current case, and then we try and solve things. All right, so generally, school has been really good at, getting you ready with the subject knowledge. You know, you get general knowledge sometimes, and, you've got past experiences. This is all your long-term memory, okay? Right, and then in terms of the environment, the school teaches you how to observe, how to analyze the problems, you look at the patterns, help you with skills to help you focus, all right? And, if it's specifically about, tests and stuff, it's about dissecting questions and understanding what the question is asking you, all right? But generally, this is what school teaches you in terms of how to process information from the environment. All right, so with information from the environment and with information from your long-term memory, you are able to come up with some sort of solution to the problem. That's the idea. Okay, so in terms of this flipped learning in chemistry, then we need to just focus on building your long-term memory in chemistry. Okay, so in the short term, it's about learning about chemistry and then making sure that it's in your long-term memory so that you do well in the exam. That's the short-term idea that this class is about. But really, it's also about helping you develop skills so that you can transfer those skills into other subjects and hopefully remember lots of stuff and help you with problems later on in life. And if you choose to do chemistry later on in life and study it, then you can also use this information about chemistry as well. All right, so we're going to learn about how your brain works and how to effectively put information into your long-term memory. Okay, because getting it into long-term memory is not as easy as it seems, and there's lots of things to think about. All right, so a simplified version of how your brain works can be split into two sections. It's about your long-term memory, which we're talking about, but also your working memory. And so we're going to discuss those two things, your long-term memory and your working memory. So let's go through how your brain works. All right, so in terms of your long-term memory, so your long-term memory is all the information that you've got in your brain and you can access easily, okay? So if you've got information in your brain which you can't access easily, it wouldn't effectively be in your long-term memory, all right? But, effectively, this long-term memory is infinitely large, okay? You can fit lots and lots and lots and lots of things inside this long-term memory, okay? And, it's kind of useful because, when you're trying to think about how to write, you've got a long-term memory of the letter formations, things like that. And even though you learnt them, when you were 2 or 3 or, I don't know, whatever, you're still going to be able to take that information and then access it easily when you do writing and things like that. So that's long-term memory. If you can access that information easily and it's effectively infinite space. All right, and then all of this information is interconnected to other bits of information in some way. All right, so in terms of letters, and letters turn into words, which turn into sentences, which turn into paragraphs, which turn into ways to communicate ideas. All right, but it's all about the idea that, the key point here is that the ideas are built off each other. All right, and this is a word that we use. The idea is that this is in a particular schema, which is effectively saying that when you organize new information into your long-term memory, it has to be linked to other things, and if it can't sit by itself, in your long-term memory. It's got to be linked in some ways, and the more ways it's linked, the easier it is to access it into current situations. So what the key idea here is that you need to build on your previous knowledge. Okay, and therefore, if you don't get something early on in the year, you need to practice it and practice it and practice it, and then you're eventually going to understand it so that you can build off that later. And I can't emphasize the importance of this in terms of chemistry. It's going to be important that you practice some of the basic skills that you learn in year 11 so that you can apply that in year 12. And even the things that you learn in year 9 and year 10, it's going to be important that you have a deep, concrete understanding of that in your long-term memory so that you can easily apply it into year 11 and 12. Okay, so if you have any gaps in your knowledge early in the year, you need to be able to make sure that you recognize that there's a gap in that knowledge and then start working on making sure that that knowledge is inside your long-term memory over the long term. All right. So how does information enter the long-term memory? It enters the long-term memory by repetition. Okay, you've just got to, and linking it to previous ideas, you've got to actively engage with that information over and over and over again until it becomes stuck in your brain. Okay, so you need to be able to take that information and do it over and over again. And so ideally, you should be reviewing your information quite often, maybe every week or every month, and you need to do it actively. What does that mean? Is that you're not just rereading your notes, okay? So something that's common across year 7 and 10 is that you'll just go, like, you want to study for a test, you want to do some study, you just take the notes that someone else has written for you and you just reread it and you reread it and you think that's going to help. It's not going to help. You've got to make sure that you're engaging with those ideas, which means that you're going to have some sort of questioning. You're going to have some sort of forced recall. So even if it's just a look, cover, write, check, right? That's one of the simplest way to make sure that you're repeating the ideas and that you've got it, and then that'll help you get it into your brain much, much better than rereading will, okay? So that's your long-term memory. This is what it is, and this is how you get stuff in there, all right? However, now your working memory, okay? So let's have a look at your working memory. So your working memory is your brain taking information from both the environment and the long-term memory and processing it to achieve an action. Okay, so it's effectively combining those two inside a part of your brain, which puts them two together, and then you can use those bits of information to come up with a solution, all right? But your working memory is limited, okay? So your working memory is limited, okay? Ideas of this is that, okay, when you get a two-factor authentication, so maybe you're trying to log into some website and it sends you a text message and you need to key in a code, right? Some people find it difficult to even remember 6 digits in a row, all right? Random digits in a row to input it. So you might have to go look at the first 3 digits, 1, 2, 3, and then put in the next 3 digits, 7, 8, 9, all right? So your working memory can't even take 6 random numbers in a row and hold it in your brain from the point that you go from your phone to your keyboard and transfer that across. That's the limitations of your working memory, okay? So because it's limited, we need to make sure that we're not putting too much strain on that working memory, all right? So the idea is that it can hold only a few things at a time, right? And so in terms of learning for exams and learning for tests, if you're stuck working on a problem, okay, and then you must continually look back and hold multiple pieces of information at the same time, you're going to quickly overload your working memory. Okay, so say you're working on a maths problem and you need to do algebra and you need to do 4 times 7, and if you're actually spending time processing 4 times 7 within that equation, you've already lost part of the information that is important within the problem. Okay, so that's why they say that memorization of basic, simple things is key, because what happens is that when your brain says, okay, well, 4 times 7 is 28, and you immediately can move on to the next thing without spending any of your working memory on that particular task, then it becomes easier to deal with the more complex ideas. Okay, so I will be asking you to be memorizing certain things so that your working memory is not strained by simpler things, okay? So for example, on the periodic table, if you look at the periodic table, you can work out what charge an ion is depending on its position. All right, so you might say, okay, calcium is in group 2, it's a 2+ charge because of its position on the periodic table. But if you have to do that every single time, it's going to take up more of your working memory, and then you're not going to be able to do the harder ideas that are after that. But if you've memorized that Ca is a 2+ ion, and it always is, then it's just simply, okay, Ca is a 2+ ion, you move on to the next piece of information. All right, so that you're not having to process that information and use up that precious working memory. Okay, so it's limited, and we need to work out ways to put it under as little strain as possible. Okay, so every person's working memory is different. Okay, and some people will be able to hold more information than others. All right, and their working memory will be better than others. But we can still try and make it a bit easier on that working memory. Okay, so in terms of that working memory and trying to make it easier for it, all right, so if instead of taking that working memory, instead of trying to remember, okay, I can work out the charge of an ion from this position on the periodic table and then working it out, right? If you've just simply memorized it and you're retrieving it from long-term memory instead of solving it at that point in time, it takes up less of your working memory. That's what we're talking about, right? And so this is called a process called, or it's not a process, it's called chunking, or it's supposed to be called chunking, where multiple ideas or, deeply memorized ideas are put together so you can use them together and use less of your working memory. Okay, so this might come down to the point where you're memorizing things, or whether you've memorized an entire process so that, okay, like I know that the steps for this particular process is step 1, step 2, step 3, so I just got to start doing it. So step 1, I need to do this, step 2, I need to do this. Instead of thinking, okay, what do I do after step 1? I can't remember. I'm trying to work out what do I do after step 1. Okay, if you've remembered those ideas, if you've got that in your long-term memory and you can easily access this, then it becomes a lot easier. So this is what we're talking about in terms of calculations. If you practice the process enough, it becomes second nature, and you can use more of your limited working memory to deal with environmental information. Like, there's 2 or 3 or 4 parts to this calculation, and you need to work out different things. So if you're stuck on step 1, you're spending all your working memory on step 1, it's so difficult to deal with step 2, 3, and 4. All right, but if you've memorized step 1, it's just like comes to you quickly, then it's nice and easy. All right, and so this idea of reducing the load on your working memory will help you deal with longer and more complex questions. Okay, and so the idea is that if you continue working through an idea in your working memory, this will encode it into your long-term memory. Okay, so this is the idea about practice and repetition. How do you get things into your long-term memory? You've got to repeat it over and over again, and you've got to have it as active recall, not passive recall. Okay, so the repetition needs to be active and not passive. Right, and that's why people will always tell you can't just cram before the test, because at that point in time it's too late to try and put this into your long-term memory. Okay, and at best you're just going to go into your long-term memory, but then if you don't continue to use it, it's going to fall out of your long-term memory. Okay, so that's why you've got to repeat it over and over again. So this diagram here summarizes the ideas that are expressed in this video. Okay, so you have the environment. This is maybe some part of the problem. Okay, and so you have to get you focus on a particular thing, and then you get your attention. Right, this is taking information from the environment. All right, maybe at school you've learned how to remove all of the distractions and things like that, but also, like, if you're finding it difficult to focus in class and focus on and work out what you need to do in that environment, you're going to have to work on that as well. But hopefully by year 11 and year 12, you're already at that stage where you can focus and ignore different things from the environment and focus on the particular task in hand. Once you're working on something with your full attention, okay, it goes into your working memory here. Okay, so you're taking in environmental stimulation, but also you are remembering ideas from your long-term memory. Okay, and you process those two things, and then you can come up with a solution. All right, how do you get things inside your long-term memory? Well, you need to go through it over and over again. So you've got to learn it, and then you've got to process it again, and then you've got to do it again, then you've got to do it again until it sticks inside that long-term memory. Because what will happen is that if you do not spend any time remembering it, If you do not spend any time remembering it, then what will happen is that it will go and be forgotten. All right. It will be forgotten. You won't be able to access it again. All right. When I talk about, you're saying you're rereading things over and over again instead of actively dealing with the information. If you're just saying, okay, I'm going to study, I'm going to take my notes, and I'm just going to sit down and reread it, right? Maybe you can have the attention, right? Maybe you have the attention there, but then it goes into your working memory. And if you're not actively doing anything with it, it's just going to be forgotten as well, right? Which is why it's important to actively deal with it, do questions, things like that. All right. So this is a bit of a start into how your brain works, and I'm going to be using some of these terms to talk to you about, what you're doing right or wrong in class. All right, so it's a bit of a starting idea so that we can get started with a more effective way to learn. All right, adios.